Okay, whatever. Let me share my screen. So the purpose of this meeting is to give you an overview of how in Kyma we are using AsyncAPI in all areas of Kyma, but the most important part is the event registry, of course, that you also are thinking about in Knative eventing. So maybe a little bit of background. If you don't know yet Kyma, what it is, it's just in 2 sentences. So Kyma, it's a open source project based on Kubernetes that we where we focus mainly on extensibility of legacy, monolith, old, huge applications, name it as you wish. So basically, the use case is that there you have a old application that you want to extend in cloud native way, but you can't really easily do it. Although there are many interesting presentations about how to go from monoliths into microservices. So one of the functionalities where we needed AsyncAPI was the way of kind of documenting what functionality is exposed by this external service, because external service can expose API and also can send events into Kyma. So AsyncAPI, first of all, is used in Kyma as a kind of API reference docs, right? So we simply in the catalog view, whenever you have all the services coming from any service broker, but also including our broker for those applications. So always in because we want to have really nice dev experience, we always in the context of the user, whenever he has to take some service and use it, create instance, you can see the docs rendered out of the AsyncAPI spec delivered by the application. So simply when you register application, you can also send the spec for us. So we render it. But then the most interesting part for you is the part about the registry. So, okay, you get the spec as a developer, everything is here, but at the end you would like to have a bit different content for you use. So in Kyma, you can extend your applications, for example, using the serverless. And whenever you write some Lambda code, you need to define when it's triggered, by what event is it triggered. So we have this functionality in the UI that you choose a event trigger for your Lambda. And here is something that I refer to as a event registry. So the in a given namespace, the developer gets a list of all the events that he is allowed to use and set as a trigger for the Lambda, and the payload of the event whenever it comes to Kyma is always delivered to the Lambda for the use. So you get list for now with version 1 of AsyncAPI, and the current version of Kyma, we support simple use case that we just return the event name and also the version, because in our case we have a use case that the application in the real time can provide a new version of the same event and send it to us. So we need to have versioning per message, per event. So that's for now what is being returned in a event catalog for a given context, for a given namespace.
It's a version for the schema, not for the event itself.
Yeah. And it's of course needed those data, but because in this case in the UI, you need those details to create a subscription, to subscribe your application to the event. So about subscription, not sure if I should talk more about it. I don't think it's important for this discussion, but yeah, we just have in Kyma our custom resource where you can subscribe your application to a given event. And yeah, you need those details that we have in our catalog. And the most important, I think, for you is how we want to change it in the future. So I'm not sure if it's big enough. Can you see this diagram clearly, or should I make it bigger first?
It's okay for me.
Okay, cool.
Okay, cool. So here, those two huge boxes, that's Kyma. And so I will not talk about how we do the persistence of the spec now at the moment, because we are now refactoring that. So how that works, so you have a external application that's outside Kyma, and it registers service. So it tells us, because again, the exposure of the functionalities of the application, we based it on Open Service Broker API spec. So we have our broker. So of course, except of all the details needed for provisioning, we also made it possible that when you register the application, you provide the URL to the spec. And we have a controller for our docs topic CR, and we call this functionality a headless CMS domain in Kyma. And we also have very generic solution for storing assets like specs or markdown documentation, or actually whatever you want. And it's we call it asset store, this component. So how it's done? So we provide a docs topic CR, and I'm going to quickly show you what it is, but I probably have to change the share screen. You probably still see the browser, right?
Yeah, just see the browser.
Okay, let me switch to the command line. Okay, you see the command line, right?
Looks good.
Okay, cool. So I'm going to show you now how this docs topic looks like. I need to take this part because it's annoying. So it's basically a resource where you can provide some inspect some display name, description, and we for our need, for Kyma need, it's a solution not only for AsyncAPI spec, but it's for any other spec and also markdown documentation. So you can specify different sources, and in this case, you can see an example of AsyncAPI example, and you can provide a link where you store the specification. So pointing to the file in the internet. And then we, once you create such a CR, we create the asset that is part of our asset store to fetch the URL. So you can then later do something like, after creating docs CR, you can get all the assets for this. So it's a resource responsible for fetching, and it also has a functionality if you want to do something with fetched file before it's uploaded to our storage. And then it's stored in the Minio, which is the S3 solution. So you get in the status of the CR a base URL to the bucket where the asset is located, and of course the name of the file under which it's created. So if it comes to the details of the definition, let me now again share the diagram. Okay, so we create the asset, and in simple case, we put it into Minio, but we use Minio and recommend Minio only for development. Yeah, because we in our case we always recommend to the customers to use managed services as much as possible. So instead of really maintaining some nice setup of Minio, like using Rook.io or something like this, we simply say, okay, on production you have to upgrade Minio chart to use the gateway, so the files really are saved in GCS, AWS, Azure Blob, whatever you want, because Minio supports this Minio gateway mode. And then what we will do with version AsyncAPI 2.0, we need to introduce something that we don't have. So of course, validation of the AsyncAPI. Then we will have to, for the customers, instead of telling them to modify the spec on their own, we will have some service that can do some basic transformation from version 1 to version 2. And we will have to provide this kind of registry parser, because for now, what you could see in the UI, that I can get this list. Yeah, for first version, we used only our special layer for the UI to do that. So we have basically in case of Kyma and console, we have GraphQL backend. So we simply have a GraphQL on a GraphQL backend. We have a functionality that is parsing this spec and giving this registry. But we want to, of course, get rid of it because it's useless for command line users. So assets store that we created, it provides and gives you a flexibility of defining a webhook services that before the spec is uploaded to Minio, you can mutate it or validate the file. So that's how we will do it. So we will basically have one file, one service that is serving any purpose for the AsyncAPI, and it will have an endpoint to which you send the spec. And we will generate a new file called AsyncAPI registry, for example. That's not defined. That's still in progress for discussions. So we'll generate this new file and create it in the scope of this asset. So it's going to be uploaded to Minio. So in return, at least that's the plan for now. Let's show the.
So in back in your example of making a simple Lambda for a selected event using a little JavaScript block, what comes back describing the shape of the event that you've selected? Does the UI help you understand what you're going to receive?
Yeah, so I can switch. First let me share maybe the desktop in general, because it's not efficient how I switch.
It's only
okay.
type. We only have support for that. Basically, these fields of the subscription that Lucas showed, this subscription CR. The schema itself is just right now just documented this object that the Lambda will receive.
But I can also quickly, hopefully that's going to work. But I can show you the GraphQL layer. I wonder if I'm using the right, yeah. Haven't used it for some time. Okay, let's do it now again. Okay, so you can see we basically have a GraphQL query that where, except of some details related in this case for specifically for Kyma, we really return very minimalistic information that is needed. So something that Ahmed said, we just need, for us, it's an event type, and the version and the description is just for the UI sake. And in future, we would like, of course, to have not only the description, but all the nice things that we can later use in different cases, like the example payload, the spec, and everything we actually have at the end in the as part of AsyncAPI. So the registry will be much richer, let's say.
Yeah. Well, one thing I heard, I'm not sure how is that going, but I remember there was an idea about providing a test function, so you can click on the Lambda that test the dry run or something like that, and then you get a UI where you can send a custom event out of the UI and then test inside your Lambda what the old does. So that will probably need to understand the schema of the event that will be sent.
Like a dry invoke or something.
Yes.
Yeah.
Like that. Yes.
So yeah, and basing on this example that we would return from the registry, you could, of course, take a sample object and inject into this test. And there are even discussions that if we have it already, if we're gonna have it already in the registry, we can even generate some objects. So for autocomplete in the UI, because it's now, you have to really take a look into the spec to know what's in the payload at the end.
Neat. Yeah.
Okay. So yeah, in general, it's just to sum up. So we have SA storage. Indirectly at the end, it's Minio. For the whole processing, we have an asset store, which is very generic, and it's not very much, let's say, dependent, and Kyma is not very much dependent on it in the way, or even maybe the other words around. So AsyncAPI, async store is not so dependent on Kyma. So even if you would consider that that would be a also good solution, so you don't have to reinvent the storage on your own, that we could extract it from Kyma. So use it in Kyma as a dependency, but maybe have it separately so it can be used somewhere else. But the headless CMS, I don't think it's useful for you. I'm not sure what plans you have others than just the events registry.
Can you show me more of the async API and how you're using that? Because from what I understand, it's more about describing the shape of the objects and their destination inside the context of that service, like coupling events to queues. But in a system that doesn't have queues exactly, I'm wondering how you're able to link what AsyncAPI is doing or telling you about that service to how you're actually going to use it internally, where you route requests.
So I'm not sure if I got your question correctly. So except of describing it as a docs. So how we know all of that. So whenever we register, but I'm not sure if it's actually something useful for Knative, but yeah. So whenever we register the application, it registers a set of service classes basing on the Open Service Broker API, and we're using in Kyma the Kubernetes service catalog. So it the connected application can say, okay, we have some commerce API, we have some whatever order management API, but we also have some events.
So, so sorry to interrupt. So Scott, I think you were meaning that the events were tied to a topic in this case, right? And what happens if you don't have a topic? Like, right? Is it what you meant?
Exactly. Like,
yeah.
So Knative is playing with the idea of the data lake, where events just go into a pool and then they get queried out. So we don't have a topic per se. We have a collection of data streams.
Yeah. So so in version 2, what we did is that we serialize topics as URLs, like they look at like URLs. So in version 2, you will have this slash, and the slash topic will be like the root topic, like no topic, like a box where you throw everything, right? And everything can go there, and you can publish or subscribe to the slash topic, and that will mean like no topic at all. That's the example, for instance, as the WebSockets. In WebSockets, you have some software like socket.io, that simulates that there are topics or channels, but they don't exist. They're just different WebSockets connections. In WebSockets, you don't have the concept of a topic or of a channel or whatever, right? So it's the same thing. So that's how we provide support for WebSockets, and it will be the same for that case.
So I guess that brings up another question. If the service providing you these events understands how it wants to namespace the events, but the integration software, as it gets into my cluster, chooses something different, is it expected that each hop in that connection rewrites the async API doc?
What do you mean? Like one of the parts will subscribe, for instance, to a subset of these messages? You mean, for instance?
Or it could, so let's say I write an adapter that takes something that's strongly queued and bridges it into a single namespace event area and changes its, so Knative is going to be using only cloud events, and no matter what the external thing is producing, they're going to get bridged in as a cloud event, and then in this way we can do this filtering and selecting if it's not on a particular channel or queue or whatever. So we're trying to abstract the details of how that thing becomes asynchronous from I guess what we're trying to do with the registry is understand where the event came from and what it's going to look like when it gets to you, but not necessarily how you find it internally, because those details are meant to be slightly opaque to the user.
Okay. So you mean and your concern is about the hops that can be in the way, like transformation that the event can suffer along the way, since it's published until it's received in the subscriber, right?
Yeah, I'm concerned that if there's data encoded in the async API that understands how those particulars happen, I might have to rewrite the document for every perspective through an integration layer.
Mm-hmm.
And I don't. Maybe I just need some more experience to know, but.
Yeah. So I mean, I had this use case before, and what I told people is to have an async API file per layer. So if you grab a message, you transform it and publish again in a different channel or in the same channel. If you're gonna do it, have an async API per service or per layer, and then in this case, what you can do in version 2, what you will be able to do is to use overlays. Overlays functionality. I don't know if you know RAML, the RAML specification. So overlays in async API is the same as overlays in RAML. So you will be able to have an async API file that you apply an overlay, like another layer on top, and you will be able to change some things of this document or add things or remove things. Usually remove things is not very common, but usually most of the times it's changing and adding stuff. So for this layer, you might want to change the schema of the message because you're going to transform it, right? So you might want to add some fields or change the name of a field because it has changed, whatever, right? And so you don't have to rewrite the whole document again. You will have the original async API document, and in every hop, right, you will have an overlay document that will just understand what needs to change to make the resulting message look like it should be, like I don't know if I'm explaining correctly, but yeah.
So the very top layer, does async API have the concept of like the minimal viable specification, like something that's just a little past what like a JSON a JSON spec? Like JSON spec's not quite enough. I need so OpenAPI, right, specifies schema for specific objects, but it's coupled to usually like an endpoint or a service. And so that's not going to work for me. And async API like sounds intriguing if I could do something that decouples it from the topic. And it's more of a way to do semantic understanding of versioned event types and their schema that's going to come to you. But
is it something you can do in cloud events with cloud events right now? Because I'm not sure.
No, it is a non-solved problem.
Okay. No, because we are not entering that layer of how the data should look like, and we'll leave it as an opaque object, and it can be anything for us from our point of view. And that's why that's the reason I was asking about cloud events, because one of the things that I want to do actually is to show an example of how to use cloud events with AsyncAPI too, both combined, right?
So because cloud events is supposed to provide a well-known envelope so that you can do like first pass parsing of an object and potentially help route that message to its destination, based on internal configuration. But cloud events also thinks of the payload as opaque.
Okay, so your concern is more about the type of event or the message or whatever, right? And not so much. So basically, you want a list of events, right? That's what you want.
Well, I actually do want so like my ultimate dream would be to enable something in Knative that allows you to register some adapter that provides something that describes what its events are going to be, like this registry idea, and then you can similarly click a button and it returns you back like the fully populated Go struct or whatever language you choose of this is the function you should implement to receive the event that you've just selected because it's on your cluster or whatever it is.
So you need the event and also the some kind of reference to the service that publishes.
I don't need to know what service made that event. I just need to know what the shape of the event will be and a bunch of like linking back to like how to look up what it does and what it means.
So just events actually is the only thing you need is just event, no topics, no producers.
Exactly. Right? That is what I'm looking for.
That's if I'm not mistaken, because that's what Lucas and Kyma is already doing. Is you can extract those messages from all the AsyncAPI documents, right? Will it be possible?
I think so. I think we just need to agree on the schema of the payload. But what Kyma's doing is very interesting, and then plus the schema of the payload, and then you get something really interesting where you can actually generate code that handles the function in a type.
So you need a specific schema for your payload inside Knative.
Yeah, exactly.
Okay. So we can create we can create a schema, another schema for Knative, and then we plug it into. I mean, actually, I'm going to explain briefly. So in version 2, we decoupled AsyncAPI from JSON schema. That's why I was saying that we don't care on what's inside the message. You can define it there if you want. I mean, you have to actually. It's not that if you want, but we don't impose any specific language, right? We don't impose JSON schema or Avro or any other language, right? And that's why we're going to start supporting something we call schema parsers, and that will be JSON schema parser for JSON schema defined messages. Protobuf schema parsers, so you can define with protobuf or flat buffers as well for gaming. It's very interesting, and with Avro as well. So and that's why I was saying before, you can use a cloud events schema parser, right? Like and then what we can do is we can have a Knative schema parser if you want. We can agree on a specific schema format, right?
Well, so cloud events is more of a transport abstraction. So cloud events can come on any sort of queuing or a request-based transport that you can support. and it's metadata to understand what's coming to you. And Knative doesn't actually have any opinions about. Well, sorry, it does have opinions, but we don't. Not necessarily making the content of the event. We're enabling, like, we're basically middleware.
Yes. So yeah, I think this is a discussion that I already had with the cloud events, with some cloud events people. Is that like using cloud events as a spec, not necessarily as an envelope. So it doesn't have to be in the message, in the payload of the message. It's more like in AsyncAPI, it's separated. You use both layers to validate the other, right? One layer to validate the other, but it's not going to be included on the final payload. It's not going to be an envelope, basically. Yeah. So yeah, we can. I think we have to agree on schema, or a certain schema for Knative. I think that's the only missing part here, and that will be also interesting for Kyma. I'm sure, because if we can make all these things understand each other, right, that would be amazing.
Yeah, that's the goal. Cool. Well, thanks so much for the demos and the discussion. That was great.
Oh, thanks.
I'm gonna still stalk around your channel and see what we can do. I mean, I don't know if maybe Kyma doesn't really want to write their own registry and they want to leverage other things. Is that true or no?
Yeah, so definitely if there's an option to reuse something, then our first rule we have, don't reinvent the wheel. So.
Yeah, but we're eager to learn from what you've learned doing this task. So I think that's why this conversation was interesting.
Cool. Scott, do you know if there's any update on the registry regarding after the decision was taken? Because last week I was not that much available, and I remember last thing it was like a tie there, right? So probably I'm guessing you guys are discussing it locally or prototyping something or something like that.
We have some ideas. Actually, Nacho has been working on it.
Yes.
Okay.
Go ahead, Scott. Yeah, I've been kind of starting prototyping some stuff, the things that came out of that UX comparison document.
Yeah.
There's still nothing defined. I kind of started a separate doc that I share internally. And once I, let's say, get the thumbs up, I'll probably post it into the group so that I can get some comments and stuff.
Cool.
Yeah.
It's a pretty complex problem that we have to think where we want to draw the line, because in cloud events, the source, like the actual resource emitting the event, can change for every message, for every unique endpoint that's actually emitting something. So if the registry is able to tie back event type to actual resource, maybe even in a temporal basis, like every event that's ever happened in the last week, in a unique source, that registry can grow very large. So we, in the background, we're also working with Cloud Events specification to decouple the unique identifier for the resource emitting the event versus the service that holds them. So, for example, if you're listening to a bucket and there's like an object change notification, at the moment, our interpretation of the spec would be that resource is the thing emitting the event because it changed. And then you can go back and find it. But wouldn't it be nice if instead of the source, or like the ultimate thing that's emitting that event is a two-part, right? Like the bucket and the resource. And then we could have the registry know about the buckets, but not necessarily the individual resources, because it's not that interesting. So we're trying to split that in Cloud Events, and it'll make our life for Cloud Events and Knative a little easier for registries.
Cool.
Yeah, we're aligned. It's fun.
Cool. Nacho, please post that whenever it's ready. No, waiting for it.
Yes.
Yeah, if you guys can come up with some example or write-up of the needs that you have, so we can have a look at AsyncAPI as well, and we might be able to provide better help than just discussing here, because just for the record, I never used Kubernetes, so I'm I'm learning along the way. And some of the things you say, it's like, what? What are these guys talking about? So if you can write down some of these things, and so I can I can have an idea on what are the needs for the registry. I'll be happy to work on that further.
It sounds great. And
Cool.
one, yeah. I think that's all I got. That was cool.
Okay. Awesome. So good. We synced. I guess we're all in contact anyway, right? Perfecto. So any objections if I put it on our Kyma channel, Kyma YouTube channel, so we can share it with anyone who's interested internally?
Sounds great.
Yes.
See you on the web.
Thank you.
Thanks, guys.
Cool. Thanks.
Cheers. Bye-bye.
Thanks, guys. Ciao.